Welcome back to VQ Intel. Today we're going to be finding limits with trig identities. The links to the worksheet you can use to follow along are down below in the comments. So, all of this is going to be working around finding limits with trig identities. So with the first one, here, if I want to plug in 0, I have 1 plus sine of 0 all over 1 plus cosine of 0. Well, sine of 0 is 0. Cosine of 0 is 1. So we get 1/2. Now, unfortunately, not all of these are as simple. If we look at the second one, here we're plugging in 0. And so if I plug in 0 for the top, I get 0, and then I have sine of 0 on the bottom. Well, like we said up here, sine of 0 is equal to 0. So I end up with 0 over 0. Now, the majority of the rest of these are revolving around this little fact, that the limit as x approaches 0 of sine of x over x, that limit is 0. Or sorry, that limit is 1. Now, x can be anything. So if you notice here, we have a 3x inside. So this limit is only going to work if I change this and say, well, in order for this to work, it should be 3x over sine of 3x. Well, I introduced a 3, so I need to balance that out. So that means I'm going to multiply by 1/3, so that balances out the 3 that I introduced. But now, I know that this limit is basically this same limit, just upside down. It's the reciprocal. Well, the reciprocal of 1 is still 1. So 1 times 1/3 is 1/3. So that is what our limit here equals. Number 3, tangent. Now tangent, that can be broken down into sine divided by cosine. So that means I can write this as sine of x on top, cosine of x is on the bottom, but x is already there. And so now I can break this up into limit as x approaches 0. I have sine of x over x times 1 over cosine of x. Now limit as now x is approaching 0, and we know that this part is going to give us a limit of 1. But what about cosine? Well, if I plug in 0 for cosine, that's just 1 over 1. So this limit is equal to 1. Number 4. Here I have the limit as x approaches 0 of sine of 2x all over 4x. Well, what do I want? We want this to match that. So that means we want sine of x, or sine of 2x, excuse me, all over sine of 2x. Well, that means I need another 2 to balance it out. So this limit right here, 2x and 2x matches, so that limit equals 1 times 1/2. So we get a limit of 1/2 for this one. On the next page, we have sine squared all over 3x. So how do we break this up? All right, here's how. Limit as x approaches 0. And so I'm going to have sine of x over x times sine of x over 1 times 1/3. Well, the limit as x approaches 0 of this piece is 1. Now we have plugged in 0 for sine already, and that gives us 0. And then if I plug in 0 for this, well, there's no x, so this is 1/3. And since I have a factor of 0 here, this limit simply equals 0. For the next one, here I've got limit as x approaches 0 of x times sine of x all over 1 minus cosine squared. So what I'm going to do is I'm going to use a trig identity. And that trig identity says, well, this equals sine squared on the bottom. And now, because I have sine and sine squared, I can cancel them. So I have x left on top and sine of x on the bottom. Well, that's just the same limit that we saw on the first page, upside down. And so that limit is still going to equal 1. So with number 7, here, similar to the identity that we used above, here we're going to write this as limit as x approaches 0. We have x squared all over sine squared x. And then I'm going to break this up. Limit as x approaches 0. I have x over sine of x times x over sine of x. Well, each one of these limits as x approaches 0 is just 1. So 1 times 1 gives us a limit of 1. All right. And the last one, number 8. Here we have sine of 2x squared over x. Now what we want is we want to have this match that. So we want to have sine of 2x squared all over 2x squared. Well, what did we have to do to get that? We had to multiply by an extra 2x on the bottom. So to balance it out, I'm going to multiply by 2x on the top. And so this limit equals 1. But when I plug in 0 here, that limit equals 0. So we get that limit overall equal to 0. Thanks for watching. If you want to support the work, links are down below. Remember, the best way to understand something is to do it.